In this section, we'll work on setting up the development environment for our course. We'll start with an introduction to Docker, install and configure Docker on our Windows 10 development environment, and other required infrastructural components used to create reactive microservices in .NET Core. If you have been following trends in the cloud world, you probably heard of Docker. Docker is a tool for running applications in an isolated environment. Docker allows any developer of any language to package an application into containers and make it easy to run on an operating system you want. This video, we'll see what Docker is and what are the important concepts of Docker. In traditional virtualization, we use the general infrastructure, on-premise or cloud, with the servers, storages, network switches, etc. The operating system is put on top of this infrastructure. This could be Windows Server operating system or Linux, etc. After that, we install or enable hypervisor on the operating system. In case of Windows, this is normally Hyper-V. Now, we can use the feature of hypervisor to emulate the hardware to create virtual machines on this infrastructure. These individual virtual machines can be prepared with a guest operating system like Windows, Linux, etc. This is also an advantage provided by this kind of virtualization that you can install different operating systems on different virtual machines on top of the host operating system. Each virtual machine has its own operating system and a kernel. This is just like a separate server with its own kernel, storage, etc. But the problem here is that each guest operating system in itself may be 800 megabytes each. That means that you're using 2.4 gigs of disk space for operating system itself. It gets worse because each operating system needs its own CPU and memory. Then, on top of this, you have binaries or libraries for your application to run. Finally, we have our application code. If you want each app to be isolated, you would require to run each app in its own operating system. So that's the story of running virtual machines on virtualized environment. Now let's compare this to Docker containers. For running containers, we again need some kind of infrastructure like virtual machines or servers on the cloud. On top of this, we need an operating system that can support containerization. All major distributions of Linux are supported. And there are ways to run Docker on Mac operating system and Windows also. The Docker daemon replaces the hypervisor. The daemon runs on top of host operating system and manages everything required to run and interact with the host operating system. Next, we have our binaries and libraries just like the same way we have in virtualization. But instead of them being installed on the guest operating system, they get packaged and distributed as packages called Docker images. Then, the Docker daemon runs those images. The last piece of the puzzle is our applications. Each one will end up residing in its own Docker image and will be managed independently by the Docker daemon. Typically, each application and its binaries get packaged into the same Docker image. As you can see, each application is still isolated. And also, the need of creating and managing hypervisor and virtual machines are not required anymore. The Docker daemon directly communicates to the host operating system and knows how to provide resources for the running containers. It also ensures that each container is isolated from the host operating system and run in its own space. The real-world difference here is that the speed in which the container starts up. Where virtual machines may take a couple of minutes to start up, the containers can complete the startup process in seconds. It can also save a ton of disk space and resources because of saving the resources for installing and managing the guest operating systems.